This is our day 4 video. It's going to be the last new topic we cover in Unit 7. We're going to be writing congruence and similarity proofs. So in math we write proofs to show our thinking. It shows our train of thoughts, way of writing it out, and explaining how a statement must be true. So in each step of the proof we make a statement, and that's what we've been practicing in class, is writing congruent statements, saying two angles are congruent, or two segments are congruent, or the whole triangles are congruent or similar, making those statements. And what's different about the proofs, we don't just make the statement, we also have to give a reason, right? So why that statement is true. So we work through each thing one step at a time, writing our statement and our reason, and that will lead us to a conclusion at the end, and that's what the proof is. It's proving that something has to be true. So it's really not a lot different than what we've been doing in class. It's just a way of writing it out. So we've been practicing writing the statements, really good at writing the statements. The reasons is what we're going to work on right now, is what are the reasons we're going to put next to each of our statements. So the first one is the new topic. It's called CPCTC. And what that stands for is corresponding parts of congruent triangles are congruent. So what that means is once we know that a triangle is congruent to another triangle, which again we can see that they're congruent using our shortcuts, either by side, 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 or side, angle, side, angle, side, angle, 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 side, or hypotenuse leg. So once we see they're congruent by checking those three parts, we know the remaining parts of the triangle has to be congruent also. But I would know that the corresponding parts the remaining parts have to be congruent as well, because they correspond to something on another triangle, and we know the whole triangles are congruent. So anytime you're writing a proof and it's asking you to prove that one piece of a triangle is congruent to another piece of a triangle, you're going to end your proof with this reason, CPCTC. So you'll work your way down through the proof, and at the end you'll say the two pieces are congruent because the triangles are congruent and their corresponding parts. So CPCTC, the corresponding parts on congruent triangles are congruent. So our second reason, we've seen a couple of these where we'll have what we've been calling a shared side. There's a property for that called either reflexive or identity property. So this is, we've seen this before. We have sides that are shared between two different triangles, so there's a side on both triangles. So a side is obviously congruent to itself. But we have a mathematical name, a special property that's called reflexive property or identity property. Or you can also say shared side, is they all three mean the same thing. So another reason you'll see a lot when we're trying to show that angles are congruent is we have a lot of different types of angles, and this is something we covered in the last unit. So one of the more common ones you'll see is when two lines intersect, they form vertical angles. vertical angles are across from each other at the intersection of two lines. These angles are always congruent. Another thing, we know that anytime angles add up to form a straight line, those are called linear pairs or supplementary angles. So if you use that property of adding up to 180 degrees to find the measure of an angle, that would be the reason you list linear pairs. And we also know that angles add up to make a right angle 90 degrees are called complementary angles. And we know that all three angles inside a triangle add up to 180 degrees. So if you find that third missing angle, you would refer to your reason. You would say triangle angle sum. So that's the property that all three interior angles of a triangle add up to 180 degrees. And then the last thing we did in the last unit, unit 6, we talked about types of angles that are congruent when we have parallel lines cut by a transversal. You won't see a lot of this, but you could see it, and it's good to review the different types of angles we have in those situations. So angles that are like 3 and 6, or like 4 and 5, across from each other on alternate sides of the transversal are called alternate interior angles. They're on opposite sides of the transversal inside of the two lines, so alternate and interior angles. Angles like 1 and 5, or also 2 or 6, or 4 and 8, or 3 and 7 are called corresponding angles. And last, angles like 2 and 7, or 1 and 8 are called alternate exterior angles. They're on opposite sides of the transversal but outside of the lines. And these three types of angles will be congruent only if the lines are parallel. So we have two more reasons we're going to review, and then we're going to go through three proofs together, kind of show you what a proof looks like. So the next one is for midpoints and bisectors. So if the given information tells you something is an angle bisector, or tells you a certain point is the midpoint, this is what you list as your reason for knowing that the two pieces on either side are congruent, either the two angles on either side of the angle bisector or the two segments on either side of the midpoint. So if you have something like that, your reason you would list is midpoint if it's a midpoint, or bisector if it is an angle bisector. And the last one is an easy one to forget, is anytime you're given information, it's either marked that way in the diagram, or it says given and listing information, you write given as the reason you know that. So the information that is given to you. So it can be marked on diagram, or it can actually be written out in words. But you list that reason. You still have to rewrite those statements and list them, and list the reason you know them as given. So we're going to work through each of these three proofs here. Just for clarification, these things I'm circling in blue, this is what we're trying to prove. So this isn't telling us to mark it this way in our diagram. It's saying, can you show, based on the information given here, that this is true? And that's what a proof is. So there's basically three sections to a proof. The first thing is, what do you already know? So if I look at this picture, I see that this segment here, AD, is marked congruent to this segment, CD. So that would be the first statement I would write. AD is congruent to CD. That's my statement, and the reason, well, it's marked that way, so it's given. So the next piece of the proof is there anything you can figure out? Looking at the angles, I can see this angle ADB is 90-degree angle, and the straight line here means that we'd have another 90-degree angle here. So I can figure out that angle ADB is congruent to angle CDB, and the reason for that is they're linear pairs, and angle ADB is a right angle. Right, the next thing I see is this side right here, BD. That segment is a side on both triangles, so I can say that it's congruent to itself. And we can say reflexive property, identity property, or we can say shared side. Either one of those is correct. So now looking back at what we've written down, we have a side on each of the triangles. We have an angle on each of the triangles. And then we have another side. Right, the angle is right in between those two sides. So now I know, given this information, that the two triangles are congruent by side, angle, side. So my congruent statement, triangle ADB is congruent to triangle CDB. And the reason I list for this is that postulate, side, angle, side. Now the last step in the proof is the conclusion. So once I know these two triangles are congruent, I look at A and C. They are in corresponding parts. Right, it's the first one right here, it's the first one right here. They're corresponding parts. The triangles are congruent, so these two pieces are congruent. So angle A is congruent to angle C, and the reason we list for that is CPCGC. They're corresponding parts on congruent triangles, so they're congruent. So we'll go through two more of those, and then we're going to be practicing some of those in class today. So same thing on number 2, we're trying to prove that the segment HE is congruent to the segment FG. So we're going to start by just writing down our given information. We see there's two angles marked congruent. Angle EFH is marked congruent to angle GHF. Right, it's marked that way, so we write given. We also have angle EHF is congruent to angle GFH. and it's marked that way in the picture, so the reason we list is given. So if I think about trying to prove these two triangles congruent, I have angle and angle. If I have a side, whether it's the included side or any other side, then I could prove the triangles are congruent. I see right here down the middle that we have a shared side. FH is congruent to itself. So again, we say reflexive property or shared side. And that gives us a side, so now we have angle, side, angle. So we can write the triangle congruent statement here for the whole triangle, so that's triangle EHF congruent to triangle GFH. And the reason here is angle, side, angle. If angle, side, angle congruence. And then looking at what we're trying to prove, we're trying to show that HE is congruent to FG. So we look to see if they're in corresponding parts. So here's HE, 2, 1, and FG, also 2, 1. So their corresponding parts on congruent triangles means they're congruent. So now we've proven that this is true. HE is congruent to FG. Their corresponding parts on congruent triangles, so they're congruent. Right, so we showed all the pieces that lead us up to this conclusion, and then from there we jump to here. So every next step leads to the every previous step leads to the next step. So to show that triangles are congruent, we have to show all the pieces, and that's what's listed above. Once we know the triangle is congruent, we know all the other pieces are congruent. So everything has to follow in a logical order. And here's a last one. This one is probably the easiest of the three because so much information is given. We can look at this right away and see that we have three pieces of given information, and we can tell just from the picture that we have angle, side, angle congruence between the triangles. But we have to write out all the pieces that make that up. So we'll start by writing out all our given information. So angle J congruent to angle N, side JL congruent to side NM, and then angle L congruent to angle M. Right, and all this information is given. And from that given information, we know the triangles are congruent by our theorems we went over on Tuesday. So triangle KLJ is congruent to triangle PMN, and the reason is angle, side, angle. So again, the order doesn't matter on that statement as long as the corresponding points match up. And then now we look at angle K, angle P. They're in the same spot. They're in corresponding parts. They're on congruent triangles, so they're congruent. So the reason is CPCPC. There's one other way we could have also done this proof. It's actually just a little bit quicker, and we'll go through that real quick. Since we see we already have two angles in each triangle, we know the third angle has to be the same because all three have to add up to 180. So we could say, this is version 2, we could say, start with angle J congruent to angle N, angle L congruent to angle M, and these are both given. And then go ahead and say that angle K has to be congruent to angle P because of the triangle angle sum. So that's a little bit shorter way. So if you want to look for other resources or other examples of this, you can search for triangle congruence proofs.